All right, so I have done the analysis, or rather, I'm sorry, I've done the experiment, and I'm now ready to do the analysis. I've recorded the time of the first drop in column C12 and the time of the second drop in column C13, and now I want the average. I want to analyze the average of those two times. So on Minitab, I'm going to go up to the Calc menu, click that, click on the calculator, and I'm going to tell it that I want to calculate flight time. And I want flight time to be equal to the average, so I'm going to put in a parenthesis here. I want it to be the average of the first drop and the second drop. And Minitab does have an averaging function, but for just two values, this is just as easy. So I'm going to click OK, and it'll create a new variable called flight time and put it in column C14. Now I want to do the analysis of this experiment. So I'm going to go to the Stat menu, down to the DOE menu, and I'm going to choose Factorial, Analyze Factorial Design, and what I want to analyze is the flight time. For a screening experiment, I want to look at all the main effects. So I'm going to tell it to include all the terms up through order 1, and it has chosen all the main effects. I'm going to click OK. And now let's look at the graphs. I'm going to choose a normal plot of the effects and a Pareto plot of the effects. These will tell me whether or not the effects are statistically significant. And for my residual plots, I want to look at all 4 of the residual plots. And I also want to plot residuals versus flight time, see if there's any patterns there. So click OK, click OK again, and Minitab does the analysis. Now I'm going to click on the Show Session folder. This is the way I like to view my results. It gives you a list of activities in the current session. And first let's look at the factorial design that we chose earlier. And this was a 7-factor design, and we had 16 runs, and you'll see that that's a resolution 4, meaning that 2-factor interactions will be confounded with other 2-factor interactions. And Minitab shows you the alias structure. So you see main effects are confounded only with 3-factor and higher interactions, and that's a good thing. So they're pretty clean main effects, and we can determine something from them. So I'm going to click on the Factorial Fit. This is the analysis we just did. And here's the terms of our experiment. We have a model that includes a constant. It's a linear model. Factors W1, W2, L1, L2, and L3, clip size, and paperweight. Those are our different factors. And we're interested mainly in the p-value column. And if you look at the p-value column, you see that the constant should be included. It has a p-value smaller than 0.05. W1 should be included in the model. Clip size should be included in the model. And paperweight, we could include it or not include it. So what I'm going to do, it's close to 0.05 is what I'm saying. So what I'm going to do is I'm going to do an analysis that includes the W1 factor, the clip size, and the paperweight. And I'm going to eliminate all these that have large p-values, because when I do that, I'm going to gain degrees of freedom, and that's going to allow me to see whether or not this 0.07 falls in. So I'll have a smaller mean square error term, and the paperweight might actually be significant. So in Minitab, I can click this icon to edit the last dialog box. And when I do, I'm going to go back to this dialog box. I'm going to click Terms, and I want to keep W1. I want to get rid of W2, L1, and L2, and L3 because these had very large p-values. And I want to run the analysis again with just these 3 values. So when I do this, I get another analysis. I'm going to look at the session window, double click on this analysis, and now I see that these 3 factors, in fact, do have a low p-values. I'm going to examine the interactions of these 3 terms. Now, the 2-factor interactions of these 3 terms. Now I know that they're confounded with other two-factor interactions, but if they still aren't significant, then I don't have to worry about that. So I'm going to edit this dialog box, go back to terms. I've got A, F, and G, and I want any two-factor interaction including a combination of those. So I have AF, I have AG, and I also want the FG interaction in this model. So that is clear down here. I'll add those terms and do the analysis again. Let's see if they have an effect. So again, I'm going to take a look at the analysis, and I see that these in fact do not have a significant effect. So all of these two-factor interactions have large p-values. They're not statistically significant. So I can go back to the analysis here and look at what in fact this analysis shows me. So there are a number of statistics calculated by Minitab. This is the standard deviation of the residuals, also called the standard error. This is called a press statistic. It's the predicted sum of the squares, and it's calculated by dropping each value and seeing what the remaining values would predict that value to be. R squared at 0.7 or 71% is quite high. R squared adjusted is also pretty good. The predicted R squared value is used to determine whether or not your model has been overfitted. That means it would be able to predict only it's the data set that was used to build the model, but not very good at predicting values outside of the data set. It should be somewhere close to the R squared and R squared adjusted. This one's smaller, but I'd call it still in range. So I think our model is somewhat overfitted, which you'd expect for a small data set like this, but it's not too bad. Now looking at the analysis of variance, the main effects, the p-value is 0.001, so that's highly significant. Residual error based on lack of fit and peer error, we didn't cover that. You'll have to ask your master black belt about how to interpret that. Observation 14 has a relatively large standard error. It's nothing to be too worried about, but it's a little bit high, and it turns out to be our very best value for flight time. So basically, this model is not too good at predicting very high values of flight time relative to the values in the middle of the analysis. Let's scroll down a little bit. Okay, so this is just our coefficient, so that's the model. So if you put this into a spreadsheet, the constant term 0.2 plus 0.56 times W1 minus 0.209 times clip size minus 0.138 times the paper weight. For these would be, by the way, a -1 for the low and a +1 for the high on these categorical variables. So here's our effects plot, and you can see that factors A, F, and G are highly significant. Oh, I'm sorry. I skipped down to the one where we had the three-factor interaction, so let me go back up here. So we see paper weight, width 1, and clip size are significant. The Pareto analysis shows that these three factors, in fact, have large standardized effects. These are effects in standard deviation units. The residual plot, now look at the normal residual plot. It's somewhat curvilinear, so it's not normal. It fits okay, but it could be fitted better, and I'll show you how to do that in a minute. The histogram shows us the problem. Our residuals should be a bell-shaped curve, and in fact, they're not. They're very skewed. I see no pattern here in terms of the observation order, and we randomized our design, so we shouldn't see a pattern there. The residuals versus fits, we have this one outlier, and we already know what that is. That's value number 14. So here's residuals versus flight time, and again, value 14. It doesn't predict it very well. The residual is relatively high, and that particular value was around 2.44. So it's a very good flight time, and would like to be able to predict it a little bit better than we did. So what I want to do now is I want to deal with this outlier, and I want to deal with the normal probability plot. Where was that little babe? Here it was. So I want to deal with this curvilinear plot and the outlier. So what I'm going to do is I know that this particular pattern from experience, I know that it's it could probably be fixed by taking a transform of the data, and the logarithmic transform would probably help me with this model. So now what I'm going to do is I'm going to go back to the Calc menu, click on Calculator, and what I want is to calculate the log of flight time. So I'll say log flight time, and what I want that to be equal to is, I'll look down here at this function list, and I'm going to try to find the logarithm. I know it starts with an L. You know, any logarithm will do, so I'm going to do the base 10 log of flight time, and I'll click OK, and it added that to the worksheet. Now I'm going to go back to the Stat DOE menu, choose Factorial, and by the way, all this is relatively advanced for black belts. It's something that your master black belt would help you do. I'm going to analyze the factorial design, only this time I want to analyze the log of the flight time. And I'll leave everything else the same. Actually, I need to get rid of these two-factor interactions because I decided they weren't statistically significant. And I'll do the analysis. Minitab will calculate the results. And again, I have great p-values, somewhat better r-squareds, a much better press value, but then this is a log now, so it's not in the original units. What I'm interested in is the plots. So again, we see the standardized effects really haven't changed much. The same three factors are highly significant. The standardized effects are still very large, but this is what we were hoping for, and that is that the normal probability plot has become much better. So instead of that curve pattern that we saw going up and then flattening out, we now have a nice linear fit. And of course, the fitted values are better as well. These are the residual plots. We still have this one out here, but what you'll notice is I don't believe that was an outlier any longer. So if you look over here, Minitab does not flag that as an outlier any longer. So our transformation, in fact, did do the job, and we have a good analysis, but if you don't have access to a master black belt, the previous analysis that we looked at would also do the job for you.